Example 1 here on discrete probability distributions is taking a look at creating a probability distribution. So here we're asked to create a probability distribution for the sum of two dice rolls. So the first thing we need to do here is create a table of every possible outcome. And note here that all of the outcomes are equally likely. So in this case what we'd get is something that looks like this. Notice if I roll a 1 on one dice and a 1 on another, then we'd obtain a 2. I could roll a 2 on one dice and a 1 on another, and we'd get a 3. Okay? And we can also do that with the other dice here, rolling a 2 on this dice first, and then 1 on this dice to also get another 3. So what we can see here is that there are 36 equally likely outcomes. One of these gives 2, 2 of these give 3, 3 of these give 4, 4 of these give 5, 5 of these give 6, and so on. So in that case, if we were to carry that rule on, what we'd get then is a probability distribution that would look like this. Okay? And here now, what we want to do just to finish here is simplify this distribution. Once we've done that, we've obtained our probability distribution for the sum of two dice rolls. So after simplifying, we obtain our final solution here that looks like this. Okay? So notice here the probability of getting a 2 after two dice rolls is 1 out of 36. The probability of getting a 3 after two dice rolls is 1 out of 18. The probability of getting a 4 is 1 out of 12, and so on. Okay? And notice here these probabilities should add to 1, and you can verify that here using either this distribution or this distribution. Remember, these are both equal. So that gives us our solution to example 1 there for discrete probability distributions. Example 2 here on discrete probability distributions is taking a look at a probability function. So from the following probability distribution, we want to determine the probability function and the cumulative distribution function. So the first thing to remember here is the probability function is defined by f of x equals the probability of x being equal to lowercase x. So what we need here is a function that satisfies f of 1 being equal to 0.01, f of 2 being equal to 0.03, f of 3 being equal to 0.05, and so on. Okay? And we know here that the function increases by 0.02 each time. So this is linear with a gradient of 0.02. Hence we might try, for example, f of x. So f of x equals 0.02x plus c. And by subbing in, say, f of 1, so f of 1 equals 0.01 here, this would give us that c is equal to minus 0.01 there. So therefore, our probability function is f of x is equal to 0.02x minus 0.01 there. Okay, so that gives us our probability function. Now we just need to find the cumulative distribution function. And to find the cumulative distribution function, we must first add a running total row to our table. So that would look something like this. Notice this bottom row here is what we're looking for. So the cumulative distribution function f of x, so this is capital F of x, must satisfy f of 1 is equal to 0.01. It must satisfy, for example, f of 2 here is equal to 0.04, so 0.04 there. Okay. So here, what we're looking for then is this equation. And what we find here for f of x, capital F of x here, is this is simply x squared over 100. Okay. Notice if you take 2 and you square it, that would give you 4. If you divide it by 100, that will give you 0.04. Try that with 3 here, so f of 3. Well, again, that gives you 0.09. And you can verify that here. 3 squared is 9, divide it by 100, and we get 0.09. Okay, so that gives us our cumulative distribution function. So that gives us the solution to example 2 for discrete probability distributions.